Hi guys, in this lecture we're going to be looking at basic binary operations, which are simple addition and subtraction. Subtraction is a little bit more complex because we can look at cases where we're subtracting more than we have initially, but we'll save that for another lecture. Let's try and cover basic addition and subtraction for now. Okay, so we're dealing with binary operations, and addition in binary works the same way as you would in decimal, with the same carry if what you have is bigger. If we're adding, so let's say we want to add 46 to, let's say, 77, okay? So regularly in decimal, this is going to be 13. Okay, so this is going to be 13, and 7 plus 5 is going to be 12. So what you end up with, so this is three digits, and these are 2 digits. So it's possible to end up with more than you had initially, especially when you're carrying over. So the same thing happens in binary when you're dealing with addition. Okay, so let's say we have 10110 plus 11011. Okay, adding these guys together is going to be 1 plus 0 is going to yield 0. 1 plus 1 is 0. So we know 1 plus 1 in binary is 10 in base 2. Okay, same way 1 plus 1 is 2 in base 10, right? So the same way we added 7 and 6 and got 13 and carried 1, we're going to keep 0 down and carry our 1 high up. Okay, so now we have 1 plus 1 plus 0, so it's the same thing. It's going to be 0, carry 1. 1 plus 1 plus 0 plus 1 is still 1 plus 1, so that's 0, carry 1. And now we have a very peculiar case because we're adding 1 plus 1 plus 1. So 1 plus 1 plus 1 in binary is going to give us 1 in base 2. Same way, because it's the same thing as 3 in base 10. Okay, so we're just going to bring it down, and since these are the last digits, we would just bring it out like so, because it's possible to end up with more digits than you started. So this is 110000 in base 2. So that's all there is to binary addition. Actually, you add the number, take care of your carries, add them up, and make sure you follow it through and bring down the last carry digits if there's any. Okay, so on the other hand, when you're dealing with subtraction, it's almost exactly the same thing you have in decimal. So let's do this. We're only going to handle the simple case of when what you're subtracting from is less than what you're subtracting is less than what you're subtracting from. In the next lecture, we'll handle how to evaluate negative subtraction with complements. So let's take this example. If you want to subtract 1101, okay, I want to subtract from this 0, 1, 1, 1, 1, 0. Okay, so first thing we can notice is that okay, so technically speaking, this is called the minuend. Okay, and this is the subtrahend. Okay, so when your subtrahend is less than your minuend, then you're going to have regular subtraction. So let's carry on with this. 1 minus 0 is going to give us 1. We can tell that, okay? But here we have 0 minus 1. So we can't do that specifically. So if I'm to subtract 7 from 62, right? So that's almost the same thing I have here. You now cancel this, and this will be a 5, and this will become 12. If you ask yourself how that happens, it's because we're adding 10 to this 2. So you add whatever base you are in to the number so that you're always able to make a subtraction. So when we cut from 6 and make it to 5 and carry 1, we're actually adding 10. So we're going to see how that works here. So move over to the next number, which is 1. And we cut this from a 1 to make it a 0. And we make this 1, 0. Okay, so that 1, 0 stands for is 2 in binary, since we're working in base 2. So in base 2, 1, 0 minus 1 is going to be 1, since 2 minus 1 is 1. Okay, and same thing can kind of ripple on over. Still, see, now we end up with 0 minus 1. So we take from here, so this becomes a 0, and this becomes 1, 0. So 1, 0 minus 1 is 1. Okay, so we can't take from this. So, we have to take from here since we're doing 0 from 1. We can't take from the next neighbor, so we have to ripple it over all the way from here. So cutting this to a 0, this will become 1, 0. Okay, but remember, this is where we need our number. So we're going to cut this, and this is going to become 1. So, you keep reducing and reducing the digits. If I were to cut this again, to go from 6 to a 5 to a 4, right? So this went from a 1 0 to a 1. So since I've cut this to 1, I can add my new 1 here, and this becomes 1 0 minus 1, which is the one I'm looking for, okay? So now I have 1 minus 1, 1 0 minus 1, which is 0. I have 1 minus, Jesus. So the same thing sort of happens in decimal. If I were to cut this 5 again, it will become a 4. So since I've cut this again, I've cut this from 1 0 to 1. This becomes 1 0. So I can do 1 0 minus 1, and that is steadily 1. So remember, now I have 1 and 1. So 1 minus 1 is 0. 0 minus 0 is 0. And 1 minus, if we can pad this up, is 0, is 0. So this is all base 2. So that's all there is to the simple binary addition and subtraction. In the next lecture, we'll look at the case where your subtrahend is greater than your minuend, right? But that's how you do simple operations. It's advisable to check before you start so that you know if I'm working with complement or I can do the subtraction straight up, okay? So thanks for watching. I'll see you in the next video.